Hello everyone! In this OpenCV and Python tutorial we explain number 1. How to read images from PNG or JPG files in Python and OpenCV. Number 2. How to display images in OpenCV and Python. Number 3. How to resize images in OpenCV and Python. And number 4. How to save images to files in OpenCV and Python. But before I start with explanations, I need to mention the following. It took me a significant amount of time, energy, and planning to create this video tutorial, as well as more than 450 video tutorials that you can find on my YouTube channel. And consequently, I kindly ask you to press the like and subscribe buttons. Thanks a lot. Okay, let's start with explanations. The first step is to find an appropriate image. For example, you can use this image from my website. A link is given over here. You can do the right click, save image as, and you can download the image. Then you should open a new folder. In my case, the folder is codes OpenCV, and you should copy the image over here. The name of the image is photo1. Here it is. Okay, let's start with coding. If you're using the Spider editor, as I do, make sure that the current active folder is the folder in which you save the file. We import the OpenCV library by typing import cv2. Then, let's load the image from the file. I will call the image as image original. And to load the image, we need to type cv2.imageRead. And over here, we need to specify the file name and the extension of the file. In my case, the name of the file is photo1.jpg. Okay. Here it is. Perfect. Next, let's provide an answer to the following very important question. How are the images defined in OpenCV? For that purpose, let's type over here whos. And we can immediately observe one very interesting thing. We can observe that our image original is actually the NumPy array with dimensions 3024 by 4032 by 3. Very interesting. We can also investigate an additional thing. We can type dtype. So let's see what is the type of the entries stored in this array. We can see that they are unsigned integer, and the unsigned integers are 8-bit. Perfect. We can also get the image shape by typing imageOriginal.shape. And we can see 3024, 4032, and 3. Interesting. Let us interpret these numbers. This number 3 means the following. OpenCV loads images in the BGR format. I will type it over here. B stands for blue, G stands for green, and R stands for red. And that's the BGR format. Note that BGR is not actually RGB. The order of colors are permuted. Keep in mind that. So these three numbers are three channels. The first channel is the blue channel, the second channel is the green channel, and the third channel is the red channel. If we want to access one of these channels, let's say the blue channel, we will type this. And over here we'll specify 0. We can call the resulting variable as blue channel. And let's see what will happen. Now, here's our blue channel. Let's type blue channel shape. And we can see that this is actually a NumPy array with 3024 rows and 4032 columns. Perfect. Similarly, we can get the green channel by typing this. And to extract the green channel, we just need to type this. And finally, we can get the red channel by typing this. And over here, we specify 2. Perfect. Let's now investigate the range of the entries inside of these images or inside of these arrays. We can do that by typing, for example, bluechannel.min, and this should return actually 0. Let's verify that. Perfect. And let's check the maximum value by typing here max. And the maximum value should be 255. So the range of the entries is from 0 to 255. 255 is actually equal to, if we take 2 to the power of 8, and if we subtract 1, we will actually obtain 255. This is because the data types of these channels is just unsigned integer 8. 8-bit unsigned integer, and 8-bit unsigned integer can store the values from 0 to 255. That is in total 2 to the power 8 different values. Now let's again look into the shape of the image, and let's focus on these two numbers. 3024 by 4032. That is, we have 3024 pixel in the vertical direction and 4032 pixel in the horizontal direction. That is, every entry of the image, for example, if we type this 1, 1, and all the three channels will actually return the BGR code at every pixel. If we mix these colors, we will actually obtain the color of the pixel at the specific location, in this case 1 and 1. Next, let's learn how to display images. To display images, we need to type cv2.imshow, and over here we need to give a title of our display. Let's call it original image. And as the second input, we need to specify the name of the image. The name of the image, or better to say the array storing the image, is image original. Now, in addition to this function, we need to call cv2.waitKey. And we specify 0. So what will happen over here? We will display the image by using this function, and this function will make sure, that is this function waitKey, will make sure that the image will be on our screen until the user presses any key. And let's execute this and let's see the output. Okay, wow, here's the image. Now, here's one big issue. We can only see one part of the image. This is because the image is too large to be represented on my screen. Consequently, I will have to resize the image. However, there is another issue. If you go now to your Python editor, you will see that the code is still executing. So whatever I'm pressing here, for example, if I press space, you will see that the Python script is completed. However, the image is still over here, and this window is not responding. So how to close this window? To close the window, we use this function, cv2 destroy all windows. And now if you execute this, the window will be closed. Perfect. So we can do this. These three lines will actually show the image, wait until the user presses the key, and finally it will close the window. So let's do that and let's see the output. Okay, if I press space, fine, the Python script is completed and the window is closed. Perfect. Next, let's learn how to resize our image. There are several approaches for resizing the image. In the interest of the brevity of this video tutorial, I will just explain the first and the simplest approach. First, let's extract the dimensions of the original image. Row original, O stands for original, call number original, and channel original. Okay, now let's define the new number of rows and new number of columns. To do that, I will type row new, column new is equal to, then I will do the following. I will take the integer part of row number of the original image divided, for example, by 4, and I will take the integer of column number divided by 4. Okay. We resize the image like this. First of all, we define the new image. Let's call it image resized 1, and we call this function cv2.resize. And we specify the name of the image. The name of the image is original image. This is the first input, and the second input is this tuple, where the first entry of the tuple is the number of columns of the new image, and the second entry of the tuple is numbered of rows of the new image. Okay, so let's execute this, and let's look into the shape of our new image, and we can see that the new image is resized. Perfect. Let us now display this image. Let's type cv2.imageShow. Over here, let's give the name resized image. Then over here, let's specify the image name, image resized 1. Then let's do these two functions, let's call them, and let's see the resized image. And here it is, looks perfect. Now finally the image can fit my screen. Here you should keep in mind that the number of the columns of the image array corresponds to the width, and the row number is actually the height of the image. So always keep in mind these things. For example, over here, when we define the resized image, we specified first of all the width and then the height. Now let's press any key over here and the image will be closed. Next, let's learn how to save images to files and how to compress them. Here's the piece of code for saving the image. To save the image, we use the function cv2imagewrite. Then we specify the name of the file with the extension jpg. Then we specify the name of the array defining the image, and over here we need to specify this imagewrite flag. In the case of the JPG images or JPEG images, we need to specify the quality. The quality goes from 0 to 100. Higher values produce better quality images. Consequently, if we want to save the image with the highest possible quality, we will specify here 100. If we want to save the image with a medium quality, we will specify here 50, and if we want to save the image with the minimum quality, we will specify here 0. So let's execute this code and let's look into the output. You can see over here that these functions returned true. Let's see our images. Here's my folder with images. This is the max quality. This is the medium quality. And this is the lowest quality. Looks very much pixelized. It reminds me of my first computer 286. The graphics look like this. Another popular file format for images is the PNG file format. Let's learn how to save an image as a PNG file, and let's learn how to compress the image such that we can reduce the file size. Here's the piece of code that I wrote that saves our image as a PNG file. To save the image, again, we need to call the function cv2.imagewrite. We specify the name of the image with the extension. Here is our original array. Then we need to use this flag for specifying the compression level. The compression level goes from 0 to 9, where 0 corresponds to no compression and 9 corresponds to max compression. So let's execute this code and let's see our files. Okay, true. Let's look into the files. Here they are. This is the max quality PNG file. This is the medium quality PNG file, and this is the lowest quality of PNG file. Perfect. Okay, that would be all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons. Thanks a lot and have a nice day.